This is exercise 53 in section 4.2 of our textbook, where it says the World Factbook 2008 reports that U.S. airports have the following numbers of meters of runways that are either paved or unpaved. So we can see how many meters, we can see how many of the runways had that many meters that were paved, and then also how many of the runways that were unpaved had that number of meters. And they even kindly give us the total number of paved and the total number of unpaved. So if one of these airports is selected at random for inspection from the airports selected or given, what is the probability that it will have in A, paved runways? Notice again, no mention of given or a condition, so it's just the basic probability. To find the probability that a randomly selected airport will be paved, we take the number of paved airports and we divide by the total number. Again, that's our first formula on our formula sheet for chapter 4. So the number of paved we see is a total of 5,146, and the total number of airports displayed in this table would be the sum of the paved and the unpaved. And 5,146 and 9,805 add up to 14,951 total airports. So there's our answer to A. In B, we're asked to identify the probability that if we pick a airport randomly, it will have 914 to 2,437 meters of runway. Didn't say paved or unpaved, just 914 to 2,437. Well, we see that 914 starts here and all the way up to 2,437 would go up to the next group. So what we need to do, again, no given in this one, so just a basic probability. We need to take the number that had between 914 and 2,437 meters and divide by the total number of airports displayed. The sum of 1,464 and 2,307 is equal to 3,771. We then need to divide by the total number of runways in our study. And we already added those together and saw that they were a total of 14,951. So there's our probability in B. In C, we're asked to identify the probability that if we pick an airport randomly, that airport will have less than 1,524 meters of runway and be unpaved. Well, less than 1,524 would be these bottom two groups, but we also want them to be unpaved. So we're only interested in the sum of the two numbers in the green box. And so that sum of 1,734 and 7,909 is equal to 9,643. Once again, there is no condition given. We don't see anything like the word given. We just want to know how likely is it we pick an unpaved runway that has less than 1,524 meters. So we're going to need to divide that by the total again, just our basic probability formula. In D, what is the probability the airport would be more than 2,437 meters of runway and be paved? More than 2,437 would be 2,438 and higher. So that would be the sum of the numbers in the yellow box. That sum is equivalent to 417. Once again, there is no mention of anything like the word given, so this is not a conditional probability, but rather a probability out of the total. So we will again divide by the total, 14,951, to answer that question in D. In E, what is the probability the runway will be a paved runway given it has more than 1,523? So we want the probability it is paved given it's greater than 1,523. Now we have to use our conditional probability. That says you take the number of ways, or the number of airports that are both paved and greater than 1,523, and divide by the number in the given. That's on our formula sheet. So the number greater than 1,523. So we look at our table of information, and again, I'm going to clear out my boxes a moment. We are only interested on top of this calculation in the number of airports that are both paved and more than 1,523. Paved and more than 1,523 would just be those three values. When we add those numbers together, we get a total of 1,881. We need to divide that by the number total that are more than 1,523. Well, that would contain all of these numbers, paved and unpaved. And so all of those numbers, paved and unpaved, add up to 2,043. And again, we're adding all those numbers in the green box there because that is the condition. They had to be more than 1,523 meters long. All six of those airports have, or all six of those numbers have runways that are 1,524 meters and greater. In F, we want the probability the runway will be unpaved knowing that it has less than 1,524 meters of runway. Knowing is the same as given, and therefore we have a conditional probability. We want the probability that it is unpaved given it has less than 1,524 meters of runway. So again, we've got to find the number that are both unpaved and less than 1,524 and divide by the number in the given, which is less than 1,524 meters. Sorry, I began talking without the recording. So we're interested in finding the number that are both unpaved and less than 1,524 meters. Well, we notice that in the red box, those runways are all less than 1,524 meters and unpaved. So we need to find the sum of 1,734 and 7,909 for our numerator. And that number would be a total of 9,643. For our denominator, we need to determine the number in our given, which was, again, given that they had less than 1,524. Well, that would be all of these that have less than 1,524. So we have to add in the additional 2,307 and 958 runways that were paved. That gives us a total of 12,908. So our conditional probability in F would be 9,643 divided by 12,908. Finally, in G, we're asked for the probability that less than 1,524 meters of runway, given it's unpaved. So once again, we have to take the number that are both less than 1,524, just using the conditional probability formula, and unpaved, and divide by the number given. And the given in this case is unpaved. So again, we have to count the number that are less than 1,524 meters in length and unpaved, and those would be the numbers in the green box, which we already added together and got a sum of 9,643. But this time we need to divide by the number of unpaved, because that was our given. Our unpaved total is given in our table. That is the total number of unpaved airports. So we'll divide by 9,805.